So let f be the function defined by f of x equals x to the cube plus f of x. Plus x. Okay, so g is my inverse, and g of negative 68 equal to negative 4. What is the value of g of negative 68? Okay, so remember, since g is my inverse, negative 68 is my y value, and negative 4 is my x value. So I'm going to find the derivative of my original function, and I'm going to substitute the x value. I'm going to have 3 times 16 plus 1, 48 plus 1. So the derivative is 49. So the derivative of the reciprocal, which is we're calling g, at the y value would be the reciprocal. Number 7, find the slope of the curve at the point. Okay, so once again, we're going to use just implicit. So we're going to have 2y times the derivative of y. So every time you take the derivative of y, you need a y prime. We're going to have to use the product rule. So u is negative x, v is y. So derivative of u is negative 1. Derivative of v is y, 1 times y prime. So the derivative of u times v plus the derivative of v times u. Derivative of 4x is 4, and the derivative of 2 is 0. Okay, so I'm going to have 2y, y prime minus x, y prime equal to y minus 4. Factor out of y prime. And then divide. Okay, so there's my derivative. So now I'm going to substitute x and y. So y prime is going to be negative 6 minus 4 over 2 times negative 6 minus 1. So negative 10 over negative 12 minus 1. Negative 10 over negative 13. So it'll be positive 10 over 13. Okay, number 8 says the tangent of the curve y equals x to the e to the negative 7x is horizontal when x is equal to. Okay, so it's horizontal when the derivative is equal to 0. Because remember, horizontal means going left and right, so that means that the slope has to equal 0. So the slope of the tangent line has to equal 0. So I'm going to find the derivative, set it equal to 0, and solve for x. Okay, since I have a product, I'm going to have to use the product rule. So the derivative of u is 1. The derivative of v is e to the u times the derivative of u, which is negative 7. So my derivative is going to be the derivative of u times v plus the derivative of v times u. Okay, so we're going to set that equal to 0. So we're going to factor out of e to the negative 7x. Okay. Use the zero product property. Okay. So e to the negative 7x will never equal 0, so this side has no solution. And then so we have 7x equals to 1, or x equals to 1 over 7. So at 1 over 7, we're going to have a horizontal tangent line. Okay, for number 9, we want to find the exact intervals on which the functions is increasing, decreasing, concave up, concave down, local extreme, and inflection points. First thing we're going to do is take the derivative. We need to find our critical point to find a, b, and e. So it's going to have 4x to the third minus 144x. So we're going to set that equal to 0. So there's going to be no place where the derivative would not exist. So we're going to factor out an x. So we get 4x squared minus 144. So we get x equals to 0. And 4x squared equals to 144. So x squared 36. Okay, so x is going to be plus or minus 6. Now we're going to do our check. So we're going to check at negative 6, 0, and positive 6. So those are my critical points. So to the left of negative 6, I'm going to check negative 7. And remember, I'm checking my first derivative. Okay, so I'm going to have a negative number. So negative 7 squared is 49, and 49 times 4 is 196. So that's going to be bigger than 144. So that's going to be a negative number times a positive number, the negative number. So remember, once you finish checking, erase it. So I need a number between negative 6 and 0. Let's try negative 1. So that's going to be a negative number. So negative 1 squared is 1. 4 minus 144, that's going to give me a negative number. So a negative times a negative is a positive. 0, a number between 0 and 6 is 1. Okay, so I'm going to have a positive times a negative. That's going to give me a negative number. So again, I'm going to check 7. It's going to give me a positive times a positive. Okay, so I'm decreasing, increasing, decreasing, and increasing. Okay, so part A would be I'm increasing in the intervals negative 6 to 0 and 6 to infinity because this first derivative is positive. I'm decreasing from negative infinity to negative 6 and from 0 to 6 because the first derivative is less than 0. And we're going to also answer E. Okay, my x value of my local min. Okay, so that's going to be x equals to negative 6 and x equals to 6. So this is a min, my max, my min. So my local max is when x equals 0. And okay, this would be because f prime changes sign from negative to positive. And this one would be because f prime changes sign from positive to negative. Find what is concave down and up in points of inflection. We're going to find the second derivative. Okay, so the first derivative was 4x to the third minus 144x. So the second derivative would be 12x squared minus 144. So I can factor out a 12. So I'm going to have x squared equals to 12, or x equals plus or minus the square root of 12. So once again, I'm going to do my check. And this time I'm checking my second derivative. So I need to check whether my second derivative changes sign. Or it's actually probably be easier to use this one. So I need a number to the left of the square root of 12. That would be negative 4. So negative 4 squared is positive 16. Positive 16 minus 12 is a positive number. So once again, once you check, erase those. So I need a number between the square root of 12 and 12. That would be 0. So 0 squared minus 12 would be negative. And again, I'm going to use 4. So 4 squared is 16, so that's positive. So that tells me this is going up, concave down, concave up. So part C is concave up between negative infinity and negative square root of 12 and square root of 12 and infinity, because the second derivative is positive. Part D is concave down from negative square root of 12 to the square root of 12, because the second derivative is negative. In part F, x equals negative square root of 12 and x equals positive square root of 12 are points of inflection. So we did 10 in class. Okay, so 11. Considering the curve defined by y equals x to the fourth plus 4x cubed, find the equation of the tangent line to the curve at x equals to negative 1. Okay, so to find the equation of the tangent line, I need to find the slope at x equals to negative 1, and I need to find the y value when x is negative 1. So part A, so my derivative is 4x to the third plus 12x squared. So at negative 1, okay, I'm going to have negative 4 plus 12, which is 8. Okay, so that is my slope. So now I need to find the y value. So the y value, I'm just going to substitute negative 1 into my original equation. I'm going to have 1 minus 4, or negative 3. So my slope of my tangent, or the equation of the tangent line, is going to be y plus 3 equals 8x plus 1. And I can just go ahead and leave it in point slope.